Okay, let's where's my status? Um, hi. What's going on here? I need to turn this on. Okay, that's my light. Let's see if the stream is going on nicely. Stream has started. Stream has started. Hello. Wow, you're the first person in the stream. This is amazing. Wow, I've never had somebody join the stream so fast. My name is Wilfred, by the way. Nice to meet you. So let me just. This is very exciting. I'm just going to pin your. It's just so instant, right? Thank you for joining in. I really appreciate that. Um, um, Not quite. Is I'm still. I'm kind of. How do I put it? I'm just working on personal projects for now. Yes, and also I have school stuff, right? So it basically limits my time. But my personal projects are just like freelance stuff, right? Yes. Okay, so let's see. Let's see what we do. Let me increase my time here because today's Saturday, right? Um. So. Oh wow, I'm so happy right now to see this comment. This is beyond my expectation. Thank you very much. I really appreciate that. Thank you so much. Honestly, this motivates me to continue doing stuff like this. Thank you. I really appreciate that. Okay, so what do we have for today? I think today I was just going to revise and solve some questions, a couple of questions, because I've not done um, you know, more questions on pointers and um, you know, stacks for some time now. So as you can see, the title of this recording, this is day 41. I'm also studying, right? So day 41, on day 41, I'm just revising um, you know, stacks and pointers, right? By solving some stack and pointers problem. So let's just rewind a bit and see what stacks and pointers are, right? So I'll just try to open my monitor here so that uh I don't lose traction. So let me keep it like this. So this is my monitor screen. I will be seeing anything I'm being asked at this time. So my other screen will be, I don't know, I have an issue with the screen, so it's not going to be available most of the time. Oh wow, that's very good. That is very good. He completed his bachelor degree in computer science. This is awesome. Honestly, I have so much plans for this channel in such a way that it's not just going to be data structures and algorithm. I'll build difficult projects here on this channel. So stay tuned. I am pleased to have you on the channel. Honestly, this is very good. Okay, so let's carry on with the questions of the day. But we're going to revise, right? So I will just open a new tab. Let me open my board. So this is my dashboard I've been using for the past couple of recordings. So yeah, let me erase the board and let's start revising with the first question. So the first question is um first palindrome. What was the first question again? This is just arrays and two pointers. I mean, okay. So let's try and solve this question first. And then I will also solve this question. This question too is very interesting, right? So which one do I start with? Okay, let's start with this first one here. So it says this number of arithmetic triplets, right? You are given a zero indexed strictly increasing integer array norms and a positive integer diff, right? A triplet IJK is an arithmetic triplet if the following conditions are met, right? So I is less than J is less than K. Norms at J minus norms at I is equal to the diff, and norms at K minus norms at J is also equal to the diff as well. Return the number of unique arithmetic triplets. So here's an example. We have norms, which is an array of these integers, supposedly sorted array, right, which is strictly increasing. So meaning, the array is basically sorted from in increasing order, right? So inputs is norms and the diff is 3. So the output is 2, which means we've found two triplets that satisfy these conditions here. Okay, so let's see an explanation. So it says 1, 2, and 4, right, is an arithmetic triplet because this 1, 2, and 4 are just indexes, right? Because item at this point, so this is 7 minus 4 is equal to 3, and 4 minus 1 is also equal to 3. 7 minus 4, which is this and this, right? And then 4 minus 1 is also equal to 3. Then we have another one here. This is going to be equal to 2, 4, 5, right? It's an arithmetic because it's arithmetic triplet because 10 minus 7 is equal to 3 and so on. Okay, so how do we solve this question? Well, again, there are hints here. You can use the hints, which is what I normally do if I don't really know the answer straight away, right? So I mean, it says all constraints are small enough for a brute force solution. Are the constraints small enough for brute force solution? So here's the constraints. Norms, I mean, the array is going to be less or equal to 3 and 200. Yeah, this is good. The difference is going to be between this, right? This is small enough for a brute force solution. How can we use 3 loops? Now, this is where, I think this basically gives it all away. How can we use 3 loops, each iterating through the array, right, to go through every possible triplet? Be sure not to count duplicates. So how do we do this? Well, this is going to, I don't think I need to, okay, let's copy this. I'll copy this inputs. As usual, I always explain on the board, so which is like a habit that I've cultivated so far. So this is going to, yeah. Okay, so here is our norms array, right? And we are looking for triplets, right? And the triplets are going to be I, J, and K. So I'll call this I, J, and then K, right? This is going to be our triplets. Let me just do it this way. I, j, and k, and they are going to be in increasing order as well, or uh, it's going to be in this format. So, I is less than j is less than k, right? Like this. So here and that. Now, we want the values such that, um, when we add an item at I, right? So let's see. So an item at j minus an item at I should be equal to the difference, and k minus num at j should also be equal to the difference. So let's say an item at, let me put here I, and okay, let me not do it that way. So nums at I, was it I or j? Hold on. Nums at j at, oh, why do I keep coming here? Let me put it this way. So nums at j minus nums at I should be equal to the difference, right? Nums at j minus nums at I should be equal to the diff. Now, and another condition would be that nums at k, right, minus nums at j should also be equal to the difference. Okay, we know in our first case here, right, the difference is going to be equal to 3, which is this one here. But there's something else that we need to, be careful about, which is the way, the indexes. I'll call this I, j, k, right? These are indexes, right? These indexes like this. So these indexes are increasing. I'll not say increasing in increasing order, but they have so they are arranged in such a way that I will always be less than j, j will always be less than k, right? So for us to even do this, in a very straightforward way, right? For us to find the possible triplet, we could take I, right? I at this point here. We could take the first item here. We could take this item here called I. This will be j, and then this will be our k, right? So we know every time, right, they will be arranged in that way. So in the first iteration, I is going to be equal to 0. J, let me just remove this here. I'll represent the array here like this. So nums is going to be equal to 0. Let me use a different color. Sorry. Nums is going to be equal to 0, 1, 4, 6, 7, and 10, right? Now, in our first iteration, I will be here, right? J will be here, and K will be here. Now, based on this arrangement, we can conclude that when I is equal to 0, J is basically I plus 1, K is going to be equal to J plus 1, right? So which is how this arrangement is, right? So, but again, we want to find every possible triplet by combining by making every possible combination with each one of the items in the array, right? So how do we do that? Well, we could start by saying, okay, so when we start, from the first iteration, we'll have an outer loop, right? We'll increase I each time we complete every operation within this loop, and then we'll have another loop again for j, and then we'll have a third loop for k, right? This will help us make every possible combination. So in the first iteration, we'll combine every value, so we'll start like this. We'll start from 0. When I is equal to 0, we'll combine the j values to it, right? We'll combine the j values to it, which is going to be, I'll represent it this way. For every I equal to 0, we'll look at j. So this will start from 1, and then we'll add the values, every possible values of k. So it will go 4, right? I'll do this 4. So our first combination is going to look like this, right? We'll calculate, okay, if this 0, right, 0 minus 1 is equal to the diff, or 4 minus 1 is equal to diff. If what's the condition again? So nums at j minus nums at I. So nums at j will be here, minus nums at I will be this one, right? And nums at k, which is this one, 4 minus nums at j, right? So this here, right, this operation here, I'll put this in front. This operation here is going to be equal to, so the first one is going to be 1, and the second one here is going to be 3, right? Both of this operation did not yield the same answer, right? Or in other words, they did not give us the same value we're looking for, which is diff. And diff here is equal to 3. It's just one of them that returned 3, right? So what do we do next? Well, we don't really increase, or we don't see this as a possible triplet. So what we do next is to increase the value of this k here, right? So k transforms, k becomes something else. K will increase because every operation has to complete in the inner loop before we move upward again by one level. So here, we'll calculate for every remaining k items in the array. So we're here, k was here, k will increase to 6, k will increase to 7, k will increase to 10, right? And then we will now move to this part here, right? This point for j becomes here in the next iteration of the j loop, right? So let me I can't represent everything here because it will be very difficult for me to actually write out all the possible iteration or all the possible calculation done in the iteration. So one way to properly visualize that is to write it out, right, in terms of code. So I'll just say this is 2367. I'll copy this, right? So let me implement that for you to properly understand it. So 2367 is in 2 pointers. I'll put it here, and this is lit dash 2367 dash what was it? Arithmetic triplet, right? Arithmetic triplet. So I'll say arith triplet. Okay, so here is our the code LEETCODE gave us. So I'll just import the type here. Now, so how do we solve this? Well, basically we were given a suggestion that we could use 3 loops, right? So the first loop is going to start for every I index, right? And the second one will be for all the j, and the third one will be for every k index. So, and that way we still respect the fact that I is less than j and there is going to be less than k as well, right? So let's start like this. So I'll say, since we are returning the count, right? So I'll say count is going to be equal to 0. And then we'll do this. We'll say for I in range length of the nums array, right? Length of the nums array. We want to do for j in range. Now this time around we want to start from I plus 1, right? I plus 1. So length of nums, and then we do this. Now this solution is a brute force solution. It is no way the most effective solution we have, But because the input is not very large, right, this will work. So again, the time complexity for this is probably going to be cubic time. I don't know if that exists, but like it's more than O of n squared, right? So I'll put k here, k in range, so we start from j plus 1, right? The length of nums, right? And yeah, so at this point we'll begin to calculate, right? We'll say if nums at, so we begin to apply the condition here. So I'll say if nums at j minus nums at I is equal to diff and this. So if nums at j minus nums at I is equal to diff and nums at where I think k minus j nums at j, sorry, minus nums at j is equal to diff, sorry, let me close this sidebar here, is equal to diff, then we begin to count, right? So we'll say count plus equal 1. And one thing we can also do is we should just print, you know, those values here. I'll put print I, j, and k so that we see those triplets each time. And at the end of the day, we just return the count. Okay, so yeah, that's it. So I'll just say let me, solution is going to be equal to this solution here. I'll create an instance of this solution class, and then I'll print solution dot, I think I have, oh sorry, I didn't copy it. So I'll copy the first case here. The diff is 3, right? So let's do it this way, 3. Okay, so with this we can return the count. So let's print this. Now you can see these are the possible triplets. We have 1, 2, and 4, and then we have 2, 4, and 5, right? And also the total count is 2, right? Which is what we are returning here, which is the actual return value of this operation. Now this is a brute force solution, which means for a much higher input, this solution is not going to be effective, right? It's going to, but let's run it regardless of what happens. So I'll just do this. I'm not sure if this can be seen though. Let me reduce it a bit. Yeah, can I wrap? Is there anything like test wrap here? Nope, you can't. So let me shift this downwards a bit. Right. Okay, so let's run this and see if it works. Now it works, right? But this again is not the best solution in my own opinion, right? Because when you begin to see you can see, right, in terms of, you know, runtime is really low with 595 millisecond runtime. This is not effective at all, but it works, which is, you know, a good thing. So we can keep this like this, and tomorrow I'll find a way to optimize this, do my research and all. Okay, so that works for this particular solution. Let's move on to the next question. So the next question would be on, I want to solve this one first, because I've solved a lot of palindromic questions that, you know, this basically becomes second nature. I mean, not entirely, but like I actually know, what exactly to do when it comes to palindromes, right? And there are so many solutions that I've used so far, right? And um, trust me, this is just me memorizing whatever solution I've used before, and being able to use it in this case. I might be wrong, but I know exactly what to do to get to the solution I want, right? Or the result I want. So learn to memorize. Learn to memorize certain things. Not the solution entirely, but like the pattern you use. So first of all, we are given an array, right? So given an array of strings words, return the first palindromic string in the array. If there is no such string, return an empty string. A string is a palindrome if it reads the same way forward, the same forward and backward, right? So here is we are given a bunch of string in an array, right? And we want to return the first palindromic string that we have. So first of all, there are two ways to do. I mean, there are two steps to this um, uh, question, right? There are two steps. First of all, we need to take a string, right? We need to iterate through the word and get the string, then check if that string is a valid palindrome, right? If it's a valid palindrome, we'll return the string and forget about the rest, right? So we are not necessarily going to iterate the entire array, given that we find a palindrome at certain points, right, and we stop the iteration. Otherwise, we go through the entire array, and if we don't get a palindrome, we just return, what do we return? Output an empty string. Okay. So okay, we return an empty string. Good. So we either return the palindrome or the empty string. Now, when we find the palindrome, right, we'll find it at a particular index. So that index will allow us to get the word in the word array, right, and then return that word instead. So now, how do we know if a string is a palindrome or not? Um, so we have a lot of ways to do that, but let's say um let me show you all the three. I think I know about four ways to do it, but the first one is the simplest one. So let's say we have a string called, I usually I most of the time this is the first word that comes to my mind. RAR. It's a valid palindrome, right? But why is this a valid palindrome? Well, if we let's say if we tag this with their index, let's say 0, 1 and 2, right? And we write this string, from back to front, right? So RAR, right? So this R here is the 2, this is 1, and this is 0, right? This and that, they are all the same, right? They read the same way forward and backward, right? So this is what makes a string a valid palindrome. Now, how do we determine if the string is indeed a valid palindrome? Well, one way to do it, which is the simplest way, is to reverse the string, right? We can reverse the string by simply, taking the last item and then adding, whatever we have here in front of it, right? RAR like this. We reverse the string and then compare, the string, right? We can just use the equality sign to compare if the strings are the same. Yeah. So in this case, this is going to be true, and then we return that particular string at that point, right? So, reversing a string would take would take O of n time complexity, because we are going to reiterate through each character of the string, right, to see which one is already I mean, we are going to iterate through the string to reverse it, right, through each one of the characters. Or another way to do it is to use two pointers, right? Two pointers is such a way that we have palindromes that have an even number of equal characters in the middle. So let me say RAR and and known. So I'll say known like this, known and RAR. Both of these strings are valid palindromes, but there is a difference. There is something that makes them unique, right? Which is the values in the middle. Now, if we could use this, right, we can actually get, you know, we can use two pointers to iterate and find if the string is actually a valid palindrome. How do we do that? So in the first case of RAR, we always start from the middle, right? So let's say we have the middle like this. I'll write the RAR again, RAR like this. Now we have two pointers, a left and right pointer. So I'll represent this left, and then this is going to be my right pointer. Now, how do we do this? So from the start, we'll put these two pointers in the middle of the array, right, or the middle of the string, and then we'll just say, okay, now since these two are in the middle, right, we'll begin to grow them outward. So move the left pointer towards the left and the right pointer towards the right, and at each point, right, we need to check if the characters, you know, at each position where the left pointer is and the right pointer is are the same, right? If that condition is true, then we continue increasing the left and right pointer until, you know, they are out of, you know, out of bounds, or, you know, they grow more than the input string, right? Then until this point, right, we need to keep checking if the character at the position where the left and right pointers are the same. So when where they appear, right, so this is at this point. So we first check left and right pointer. They'll all this will return, you know. So let's say this string here, this is S. Oh, sorry, this is S. S is equal to RAR. So character at RSL has to be always equal to S at R, right? Now, once this condition is met, right, we know that so far our string is adopting the, you know, the, I mean, our string is so far a valid palindrome, but we still need to, you know, push the left and right pointer towards the borders of the entire string, right? So which means we have to move this here and then this here, and we check again, you know, are these characters the same, or are the values at this point the same, right? We'll need to check this all the time. We'll need to check this condition every time we iterate, right? What am I doing? We need to check this condition every time we iterate, and once this condition is met, right, we keep increasing the left and right pointer until we increase it to the point where we are actually outside the string, and this is no longer valid, right? Because we don't have any value here, right? There's no character here, there's no character at this point, and we know by that time we had already validated every character in the string, and now we are sure that the string is a valid palindrome. Now for the even string in the middle, right, or even characters in the middle, instead of starting the left and right pointer at the same point, we'll start the left and right pointer at opposite sides, right? And then we just do this, we'll just increase. So at this point we compare their values, right, and we'll increase this by 1, increase this by 1 as well, and, you know, check this condition every time. This condition here, we'll check this condition every time we are moving the left and right pointers, right? So we'll do this, and until we get to the end of this, or the outside the beginning and outside the end of the array or the string. And yeah, so that will simply mean that we found a valid palindrome, right? Or the string we are looking at currently is a valid palindrome, and we'll return it. So either way, right, I think we are going to have a loop within a loop, right? So let's go ahead and implement the first solution. I can just do it this way. Where's it? So use the valid palindrome question. So we'll be given an array as input, and we'll validate each one of them. So whichever one we find, we will return that string. So let me do this. So let me show you an easy way to reverse a string. First of all, I'll use my playground, right? I'll call this I'll say string. No. Let me call this a fruit, right? This is going to be a fruit, and I'll set it to mango, right? And I want to reverse this string. There's a trick to do this, right? And so this is how we do it. So we'll first of all iterate through the entire string. So I'll say for I in range, the length of the fruit string, length of fruits, right? Come on, what am I typing? Okay, right. Then what we'll do here is we'll take so we are changing the string, right? So we reset. I'll call this a reverse. I'll call this reverse string, and I'll say reverse string is going to be an empty string for now, right? So I'll reset this reverse string every time. So I'll say the reverse string is simply going to be the reverse string itself, right? The reverse string plus the the value in this string here, right? So I'll say fruit at I, right? This will simply reverse the string for us. So let's print the reverse at the end. So print reverse string, right? So when we print this, you can see we still have mango. Hold on. The reverse string plus fruit at I. Hold on. Wait. What's happening? Reverse string here. Print the reverse string. Print reverse string like this. Let's see. Mango. We are doing this is supposed to change the string. So we want to take the previous value, right, which is, and then we add the new value to it. Okay, so instead of doing it this way, the current one plus this. Yes, so this is how, so we add the current value before we add whatever the previous string was initially. Yes, so here you can see we used to have mango, but the reverse form of mango is this, right? So if mango was a valid palindrome, right, and we did this, we say print reverse string is equal to the fruit, right? This would have returned true, but it's going to be false, right? It's going to be false, which is this here. But let's say I use RAR, which is my usual string, right? Even when I reverse this string, right? Even when I reverse this string and I check for this condition here, this will give me true because it is actually the same. RAR still reads the same as this here. So yeah, and this is the only operation we'll perform within that string, right, as we are iterating through it. So within the array, as we are iterating through the word array, within the word array, yeah. So let me just come here. Did I not solve that question? What was it? So this is going to be, I don't know, I should put in 2 pointers, right? Because I mean, valid palindrome is basically a pointer question. So let's see, what number is this? 2108, first palindromic string. So I'll copy this. I can even implement it here straight away, right? And then copy it. But let me just do I mean, the normal process is to do it from my code editor. So 2108, right? So I'll say leet dash 2108, and then I'll say this is first, right? First sorry, palindrome. First palindrome. Yeah. Okay. So I'll paste this here and then, import this. All right. So here we go. Let me close this, and here I'll close this one here. All right. Here you go. So what do? Well, we'll have to iterate through the words array, right? So this is going to be an array, which is our input, and this will contain the words we want to check the valid palindrome conditions for. So for I in range of the length of the word, right? So length of words, right? Length of words. We want to validate the word at I to see if it's a valid palindrome or not. So I'll create a helper function that will help me do that. So I'll define I'll call this check palindrome, right? Check palindrome, and this will take the word we want to check for, or we just pass it the index. We'll pass it the index, and then we'll pass it the index. I'll just say index here. This index here is an integer, so good. And yeah, so I'll say this takes, so we'll take the word is just going to be words at index, right? And we'll say for I in all, to not confuse it, I'll just say for j in so we want to reverse this word here, so I'll create a reversed word, right? I'll call this reverse word and set to an empty string here. So this will be for I in range of the length of this word here, right? We want to reverse it, so we just say reversed word is simply going to be equal to the word at I use j, the word at j plus whatever the reverse word was. So reverse word here. Okay, so this reverses the word for us, and then we'll check here. So I want this to return true or false, right? So I'll just say return I think boolean, yeah. So here we'll say return true if reverse word is equal to the original word, else return false, right? Now we know this will return true or false, right? Palindrome, not drome like this. Okay, so we know this will return true or false, so we'll say I'll call this results, right? Results, and I'll say result is going to be equal to whatever we have from this. So check palindrome, I will pass it I, right? So this is going to be the index, and I will say if results, right, then if result is true, then we'll say return words at I here, right? So if it's true, just return words at I, and this will return the first word for us, and that's all we need to do. So I'll just say solution. Let's just you know what, I'm feeling a bit lazy, so let me just copy this and paste it. All right, There's no need for that. Let me just do it first. Solution, because this actually helps test it faster. So I'll call this solution, create an instance of the solution class, and then print solution dot first palindrome, right? And I'll take this here, I'll pass this in. So I think we expect only one input. Okay, so which is the word? So we'll return which word is our valid input. You can see this is ADA, ADA. All right, so yeah, which is the output here as well. I think that's all. That is all. But you know, this can be improved as well, right? We can do more than this. We can, you know, make the solution a bit faster than this. But I don't see, you know, well, I mean, it is possible to implement a faster solution, although this is O of n squared, right? This is a quadratic time operation. So let's see what it gives us. What it gives us. Oh, there's an error. So what is it? Okay, when we don't have. Oh, okay. Sorry, my bad. So when we don't have a valid palindrome, what do we return then? So if we don't return word, then we just say, okay, return an empty string. Return an empty string. Yeah, and that's all we needed to add. So I'll put it here too. So if we don't have anything returned here, so we just return the empty string, return the empty string. Yep. So let's see, this should pass all test cases now. Yep, it's good. We are good to go now. So let's submit this. I strongly believe this is not going to be the yes, exactly. See, this is 5.1. Wow. I mean, it works, but like, it's just saying that there are some cases this will perform very terribly. So how do we optimize this? I mean, instead of doing it this way, right, reversing the string and then comparing it is just a lot of work. I'm not sure if I should optimize this here and now or do it tomorrow, because there's another interesting question to solve here, which is this: design the browser history. Let me check the chat and see. Wow. Okay. Code forces. What is that? I'm not sure what this person meant by sharpen your brain, but okay, fair enough. Let me see what is code forces. Code forces. Is this code for? Oh, wow. Home, home again. Home again. Wow. I think, I don't know. This is a coding platform. I mean, I'm still learning data structures and algorithms, so I'm not sure I'm ready to. I don't know. I could try some questions here, right, and try to solve them, which is good. Good recommendation. Thank you, by the way. So I'll have a look at this later on and see how it is. Okay, so let's move on to another question. Or do I optimize this now? What do I do? Oh, sorry, I've done this. I could. You know what? You know what? I'll do that tomorrow. Yeah, it's better for me to just finish the questions I've said today, right? Instead, and then just improve this. And I know one of the best ways to improve that is to just use the other suggestion I made, which is to um who is there? Okay, which is to start from the middle and increase the two pointers outward instead of reversing the string and comparing, right? You know what? Let me just do it now. Let me just take the time and do it. Let me do that. Let me do it. Yep, I'll do it. So how do we do that? Um Let me go back to my code editor. I would keep this here, right? I'll keep this here as okay. Let me just leave it. What do I do now? Should I just say solution 2 or just delete this entirely? I'm not sure if I should do that. But you know what? Let's keep this in the okay, let's do it in the playground instead. So we want to so I'll copy this part. I'll copy this part here and put it here. Okay, so let's say this. So we will try to I'm not sure if that solution is going to be very effective, but hey, so we are going to use a two pointer to solve this, right? So let's say we start from the middle. This is a 2. So how do we get the middle in the first place, right? How do we get the middle in the first place? Well, the middle is basically going to be the length of the array divided by 2, and then we take that middle, right, and start our pointer from that point, right? So this is the left and right pointer, and then we'll move these pointers, right? We'll move them outward until we get to a point where the strings are no longer valid, right? So here, okay, let's do it that way. And instead of reversing the string, that will not work. So I'll first of all find the middle of our array, right? I'll say this is the middle. The middle is going to be the length of the array, right? The length of the particular word in question. So you know what? We are still going to iterate through everything. So let's start. Let's just start like this. For I in range length of words, right? I'll use words, and then I'll say word here. Okay, so the first the first thing we need to do is to implement that brute force solution. So here we'll provide the word instead, and I don't like to pass in the word. I would rather pass in the index. So I'll call this define validate what did I call this one here? Check palindrome. Okay, I'll still use the same thing. Let me just copy it like this. Here. Okay, so I'll say here we'll have a word. I'll say this is going to be my word. Word is going to be words at I, right? Now we'll get the length of this word here. I'll say length middle of this word. The middle is going to is not the character in the middle, it's just where the middle is, right? So it's simply going to be equal to the length of this word here. I'll divide this by 2 and round it up, so this is going to be rounded. And You know what? As I'm doing this, I like to show what happens under the wood. So let me just take this here. I'll move this to this part. I'll call this the same name, which is 210, but I'll call this improved. I'll say new file, leet dash 2108 improved. Yeah. So let's put it here. All right. So we have this here. So let's say, for instance, the length of our word, right, is so let me copy this, or let me do it here. I'll create this word. I'll call this fruit again. Sorry, fruits, and set it to equal to an array of. Or let me call this word instead, because I might set it to something else that is not a fruit. So I'll say this is RAR, right? And I'll do this print. Okay, middle, right? Middle should be equal to word. So length of the word divided by 2, right? So the length of the word is going to be equal to 3 divided by 2 in this way is just going to return 1. So print middle, right? So print middle like this. Now you can see this middle here is 1, so which means our left and right pointer will start at this point here, right? Now when we start at this point, it means both the left and right pointers are going to be equal to this, right? So what do we do next? Well, let's carry on. I'll close this. Where is this? Okay, so let me put a pass here for now. So we have the middle, right? Now we need to know what this so we have middle here, right? This is our middle. We need to know where the left and right pointer will start from. And for us to know that, first of all, we also need to get how do you call it? We also need to get for the let's say this here is known. Let's say this is NOON, which means it has an even middle, right? Or it has 2 items in the middle that is the same. So I mean, even though this starts from 2, right, which is here, the left pointer has to be here, right? 2 minus 1. So, and then we'll begin to increase them outward. So how do we do that? Well, we'll say, so we'll create the left and right pointer, right? Left and right pointer. I'm thinking, do I put the condition first? Wait, how do we check if something is even or not even? So if we do this, the result modulus 2, right? This will give us 0, right? But if the word was more than this, let me just put it in blue. This is going to be what? 5. Do we need this? I think we should. We do need it, because here we have 5, right? 5 divided by 2. This is going to give us 2 modulus 2, but this doesn't mean it started from the middle. Interesting. So let's see, what do we do here? We need to start from the middle, right? And we have 2 possible middle. A middle with a single character and a middle with 2 characters. So this will not always work. As you can see, it's giving us 0. I don't know why. This should be 0, right? Or instead of doing, oh, okay, so let's say the length of the word is this instead. Length of the word modulus 2. Yeah, so if we had 1, right, we know that it's even length. Okay. So the middle will serve us as the starting points. Okay. All right, so let's do it this way. So I'll say my left and right pointer, right? So I'll say is even. Let's just say it's even. It's going to be equal even middle, or let's say has I mean, I just want to represent this, right? I just want to say the middle has 2 characters. What variable could I possibly represent that with? Has 2 or 1, or has 2, right? Let me just say has double middle. Okay, let's call it has double middle, right? Has double middle, and this is going to be equal to the length of the word, right? Of the word, the length of the word plus, modulus operator 2. So when this is equal to 0, right, it means it has double middle, which also means that the left and right pointers are going to be on opposite sides. So let's create our left and right pointers here. How do we do that? So I'll first of all create the left and right pointer as test. Let me say left is equal to right is equal to, let's set them all to 0 first, right? And we say if the has double middle, right, this will be 0. So I'll say if not, right? Because when you do, I'm coming. When you say I'll do this. I'll say yes, right? Yes, print yes. If 0, else no, right? This will print no, because 0 is falsy. But if you say if not 0, right? So if not this, okay, I'll call this has single middle. So if not has, single middle, which means it has double middle, right? Has single. Then I'll say the left and right pointer, right? So the left pointer is going to be the middle minus 1. So it's going to start from the middle minus 1. So this is going to be equal to middle minus 1, and the right pointer is going to be the middle. So it's going to be the middle here like this, and else we'll just do this. We'll say how these are setting well. Else we'll say the left pointer here is going to be equal to the right pointer, is going to be equal to the middle, right? And then we'll start our iteration, right? So while the um while I'll say while the left and right, so at this point we would have set them right, so left and right pointer. So this will start from the same point. So while the left pointer is less or equal to the right pointer, right? Because it should always be right. So we'll do this. So while left, I can't say less than, because at this point they are all the same. They are going to be the same middle if they have you know, a single, if the string has a single letter in the middle, right? We have to start both left and right from the same point. So while left is less or equal to the right, now we need to check here. We need to check if the character at the left pointer, right? If so the word at the left, if the word at the left is not the same as the word at the right, word at right, then we just return false, else we just say increment the left and reduce the right. We push the left towards this side, right? So by reducing it, so left is just simply going to be equal to left minus 1, or let me just do it this way, minus equal 1, and right minus plus equal 1 plus equal 1. But when it gets to the point where these two, I mean, this is always going to be true, might end up in a listen. So I'll say while left is superior or equal to 0, right? Let me do it this way. And right is also equal, superior or less than the length of the string word, right? Length of the word, then want to increment that. So when, I mean, in the case where the loop is done and we didn't return any false at this point, then we know that this is a valid palindrome. So I'll just return true here. So this is going to be true. Let me just add some space here, right? Okay, so this is going to be true. Yeah, so we just say results is going to be equal to it's going to be equal to the check, and the check takes an index, right, which is I, and then we say if result, yeah, if the result is true, then we return the result, right? Else we just return false, or sorry, we return an empty string. Okay, so it doesn't recognize this as, so I'll just put true. Why? Expected string bool. Oh, sorry, return. Oh fuck. Oh, sorry. Returned. I didn't mean to say that. Words at I instead, right? Sorry. And then otherwise we just return an empty string. return an empty string. So let's say, let's say this. I'm not sure why this is still dim. What's going on? Local variable never not was not used. How? Okay, you know what? I mean, with this, hold on. I'm not sure why that is there, but let's copy this and see whether we'll get our answer. So let's run this. Yeah, this prints ada, which is this one here, right? I mean, let's say there is no, what do we get? An empty string. Okay, that works. Let's try out this. The reason why this is this is better is because, you know, this will return false earlier than here, right? Because here we are reversing the entire string before we check if it's a valid palindrome or not, right? So this will return false earlier, and then we'll go to the next item, right? So that's just my assumption. Let me copy this and try it in LeetCode, right? So we'll try it as our second solution. This was what, 5.8, right? 5.8. I'll just paste this instead. Although this seems wordy, but it is really not complicated at all. So unindexed does not match any other for I range in n of words. What's this? Oh. Wait, what? So we are supposed to be here, right? And this goes. Oh, I see what happened. Hold on, I was just okay. So let's copy this properly. I would take this again all the way to this point instead, and then do that here. Yeah, so this works. Let's see if this will be better than this. This was 136, right? 136 and so on. So let's see. Well, it's slightly better, right? It has been improved from 136 to 78. So, I mean, it's still not the best, but it's better than what was there before, than the previous submission. Okay. I think I think I am out of time now. I just have like 30 minutes left, which is not very much, because I have to. This question would take me a couple of minutes to explain, but hey, let's go over it. Oh, so they were chatting in the comment section. You see, my network is so bad that I don't even see them on time until I refresh the page. Okay, so here is Coda X. Oh, you did good, bro. Thank you very much. Ransom. I think this is not the first time Ransom is here, right? I'm sure I remember Ransom. So Ransom said, I'm learning Python on step at the moment, and I just saw your live. Oh, okay. I thought you were here before. Oh, nice to have you here. So, yeah. So, where are you from? I'm from Nigeria. Yeah. Okay. And think then, when was the question? Um, I'm a hero. Oh, wow. Yeah. That's a very funny one. Okay, what's the time? Um, okay, what's the time counter on the right about? Is it this one here? This, I think here, right? This is just to measure, it's called the big O notation, right? So, I mean, LeetCode has their way of measuring how effective your solution is, which is, the time complexity. Yes, the time complexity of your solution. How good your solution is, right? Good compared to every other solution. You can see this beats 49.20%. In terms of memory, it did well, which is, I think, approximately the same as the previous one, 16.5 MB. And oh, this is the old one. Oh, come on. Yeah, 16.59. But this year is 136. So on average, there is a metric, there is a measurement put in place for those, when you solve, where your question is fast, right? Where your implementation, your solution has a faster time complexity. This is where you can see that, right? It shows you how effective your solution is compared to others. So let's carry on with the oh, 11 minutes. Oh, 11 minutes left. Okay, it means the time I said to record uh the this session. I mean, I do it for some time. I'm not doing this. I don't want to go more than 1 hour, right? Sometimes I do it less than an hour. Sometimes I do it, you know, um about an hour. Coda X, bro, you did wanna. Thank you very much. Thank you very much for your kind comments. All right. Um. Right. I will do even better to explain more. You know. Going forward. Um. Where are you guys from? Let me interact with you guys as well. Where are you testing from? Where are you chatting from? Yes, the live is going to end in 9 minutes, but I'm planning to end it before that. But I'll just use the remaining time to interact with you guys. So, where are you chatting from? Oh, nice. Wow, nice to meet you. My name is Wilfred. Let me put my name here. You can connect with me on LinkedIn as well. Wilfred is my name. Yeah. Okay, Coda X. I'm sure Coda X is no longer here. Well, anyways, nice to meet you, Ransom. And yeah, so I will still record tomorrow again, right? I do it every day, every day, every day. Thank you. All right. Okay. Thank you very much. Thank you, brother. Sorry, I said brother. I don't know. I'm sure. Sorry, if I you know uh mistake you, if you're a boy or a girl. I'm not sure. So um sorry about that. Okay. Oh, Koda X is from India. Wow. Nice to have you here, Koda X. My name is Wilfred, and I am from Nigeria. Yeah, nice. Okay. I think we are pretty much done. I'll solve the next question tomorrow. I'll have time to revise properly and try to be clear and more um better with better explanation. Uh, Not Manchuria, it's Nigeria. Nigeria. It's in Africa. Nigeria. Yes. Yes, Nigeria. It's in Africa. Yeah. Yep. 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 All right. It was nice having you guys today. We'll see tomorrow again to continue with a new topic. I think I tomorrow I plan to I don't know. Hold on. For the coming week, I probably will be very busy, so I think I will just you know try and be very moderate because next week is going to be busy. All right, nice to have you guys here, and I'll see you tomorrow. The stream ends now. Bye.